Welcome to Global Information Security Society for Professionals of Pakistan.
My profile, but just quickly, of course, I'm Pakistani. I was in Pakistan to the age of 4, and after 4, I spent most of my life in the UK. I've worked in and graduated from London. I've also worked in Europe, in Ireland, in New York as well. My last job before I came to the Middle East was for the Bank of Ireland, and then I came and joined Thales, a French company in Dubai, as cybersecurity manager for Dubai Metro. Then I helped establish the Nozomi networks. If you don't know what Nozomi is a market leader in industrial IDS systems. And then I joined Fortinet 3 months ago, over 3 months ago now. If you have any OT specific questions, please do ask. Stop me and ask straight away. Don't save them for later. If I'm speaking too fast, stop me and ask me to slow down and speak. If you want me to explain in Urdu, I can explain in Urdu, but naturally English is easier for me. I apologize for that. Inshallah, my Urdu will improve. I am assuming in this session that all of you are at least aware of some basic IT principles and cybersecurity principles in terms of what is a firewall, what is.
Kashyap bhai, start kar lein, please.
Yeah. Can you hear me? Hello? Can you hear me?
Yeah, we all can hear you.
Yeah, okay. So yeah, I've started. For that, whoever asked me to start, I've started. Don't worry. Yeah, so please do, if I'm talking about a particular acronym, for example, if I say IOC and you don't know what IOC means, please stop me and tell me to explain what is IOC. If you don't know what the difference between what a deep neural network is, please stop me and tell me to explain what is a deep neural network, all right? So yes, I expect you to speak, all right? So let's first get into some definitions. So the first part of this presentation is to explain what is OT, what is ICS, what is SCADA, right? So what is the difference between IT and OT? IT, or information technology, I'm sure you all know what it is, right? It's computers and routers and switches and these things, and they interact with each other and they process data, right? Information. OT is technology, meaning hardware or software, that interacts with the physical component, the physical device, all right? So in IT, for example, your Windows PC may contact and upload information to a server, or be connected to a domain controller, maybe a file server, maybe a web server, etc., all right? Operational technology means any kind of software or hardware that is connecting to, for example, a valve, a pump, a sensor, a camera, anything which is interacting with the real world, physically interacting with the real world, okay? So I hope that definition is clear, all right? That's OT, operational technology, right? SCADA and ICS are subsets of OT. So ICS simply means OT, which is concerned with industry and industrial processes, right? And within industrial processes, you have distributed control systems, DCS, right? So a DCS is a type of ICS, but it's distributed, meaning spread over many, many locations. SCADA is also one type of ICS, and ICS is one type of OT. So SCADA stands for Supervisory Control and Data Acquisition. What that means is management and collection of data, right? So a SCADA system will have a master, a SCADA master, and it will collect information from a SCADA slave. It will also control the SCADA slave. So it will send instructions to the SCADA slave to tell it what to do with the real world physical device, all right? Field sensors and actuators. So the field network is known as the network which is connected to physical devices. So the network which connects to a mechanical arm or a forklift or some sort of physical speed control or pump or valve, water pump, etc., right? Gas valve, pumping gas, whatever. This is the field network. And within the field network, you have two types. This is the field network. And within the field network, you have two types or two broad categories of device. One is a sensor, which collects information and sends back information, like logs, right? but it's general for any kind of information. And actuators are things that make something actually happen in the real world. That's why they're called actuators, all right? So this is the two types of field devices you get. So there's lots of definitions here, and if anything is not clear, please do ask. Here is a typical example of SCADA architecture. You have the MTU, or the SCADA master, sitting here, right? So I'm assuming you can all see my pointer. This is the MTU, or the SCADA master, all right? The SCADA master is like a server. It's controlled by an operator, and the operator has in front of him something called the HMI. The HMI is the human-machine interface. This terminology for HMI is now archaic, is out of date, because all it is everywhere I've seen, it's just a Windows workstation, right? But traditionally, a HMI would be a panel, a control panel with physical buttons and levers that you would pull down and push up, and you would push the buttons, right? So that was traditionally a HMI, physical control panel, right? Now they've moved to Windows workstations, and those Windows workstations have specific software installed upon them, which interacts with the MTU or SCADA master here, right? And this MTU or SCADA master controls the RTUs, the remote terminal units, or the PLCs, right? So what are RTUs and PLCs? RTUs and PLCs connect to the actuators and sensors. The difference between an RTU and PLC is the RTU is usually much larger and connects to a distributed control network sometimes as well. The PLC is much more flexible, but the distinction between these two is becoming increasingly blurred. It's a gray area now, the difference between them. As technology is progressing, sometimes you'll find that RTU and PLC is used interchangeably. Sometimes you'll find PLCs modules plugged into an RTU unit. And sometimes you find something that advertises a PLC but functions more like an RTU as well, and it's a hybrid device. So basically, the PLCs and RTUs connect to these, right? Valve, fan, pump, etc. So i.e. what is known as the field network, right? The main distinction is that the PLC is programmable, right? You use something called ladder logic, for example, to program a PLC, and it stands for Programmable Logic Controller, right? So it can perform very specific things that you want, that the client wants, to the field network, and the RTU is more general purpose. I hope that's clear. What I'm showing you now is what has become the ideal standard of architecture in ICS networks, right? This is called the Purdue model, right? From the University of Purdue in America, right? And this has been adopted. And this is, you know, if you comply to this, you'll also help you in complying to other standards within the OT world, like IEC 62443, right? So let me explain this quickly. So level 0 here is also known as the field network. It's out in the field, out in the real world, right? And here you have your valves, pumps, AKA your sensors and actuators, right? So you can see this is the physical machinery, right, at the bottom. The physical machinery is controlled here by level 1, which is also known as the control network, right? These physical devices, these PLCs and RTUs, are directly connected and controlling these field devices, right? These traditionally were connected up to a local HMI or a SCADA master. This diagram is not showing it. Here you could also have, this machine could be a SCADA master or a SCADA server, right? Traditionally, they were connected via what is showing here is vendor-specific bus. But now, most of the clients that I'm dealing with, they're using standard Ethernet connections here as well. And this is a standard Forti switch or Cisco switch here as well, all right? So this is, from level 1 upwards, it's all standard Ethernet connections. And because it's standard Ethernet and it's connected via standard switches, it opens itself up to this kind of standard attacks that you may find in the IT world, right? So anyway, level 1 is the PLCs and RTUs, right? Level 2 is the supervisory level. So here you have the SCADA master, the local HMI, etc. All right. Then level 3 is what we would call it in the IT security world, like the common shared services, all right, or common services. So up here you'd have the data historian, all right, which uses the PI Connect. These devices down here will send data up to this historian, which will log and record, like a log server, the behavior and even sometimes the project files that determine the behavior of the PLCs here, right? So that's the historian using most commonly the PI Connect protocol. You'll also have the Windows domain controller, the active virus, and all other third-party common shared services you'll find here to support this network here. But the industrial network is up to here, right? Levels 0 to 3, right? Now, traditionally, industrial networks were air-gapped, so there was no connection up to enterprise admin, which is level 4. Enterprise admin means the traditional IT network. So if you think of an oil company will have its IT department with its IT equipment, and which is controlling the IT equipment of the standard desktop users. And they'd have a separate OT network, which would be related to the field network, out in the field network, the physical machinery, the oil rigs, the offshore rigs, all of these things. And that was separate, right? Now what's happening is they're connecting the two, which is this connection here through this firewall between level 3 and 4. And then level 5 is the standard internet DMZ, right? So this is not to be confused with the OSI layers. The OSI layers layer 1 to 7. This is levels. Do not confuse layers and levels. When someone talks levels, they're talking about the Purdue model. When somebody says layers, they're talking about the OSI model, all right? And we'll come to this diagram in another way later on in this presentation. So where do you find OT? The simple answer is you're finding OT now everywhere, right? I'm surprised nobody asked me the difference between OT and IoT. So quickly, IoT is a type of OT as well because it's real world interaction, but it's of course internet connected as well, not necessarily just connected to the enterprise network, or the IT network is connected to the internet as well. So IoT is also one type of OT, and a lot of the information in this presentation is relevant to IoT. So here you see, for example, OT in cars is a type of IoT if it's connected to the internet, right? OT in healthcare would also be a type of IoT because they're usually connected. And 5G will only make this technology, this type of technology, more and more widespread, which increases what we call the attack surface. But what's the problem? What are we trying to address? And what's the difference between traditional IT and OT and how they're converging, right? So traditionally, like I said, OT was isolated from IT. So if you guys remember the Stuxnet attack against Iran's nuclear program, that network was what is called air-gapped, right? It had no connection to the IT network. It had no connection to the internet. It was completely air-gapped, right? That is the traditional model, right? But increasingly today, you have a bridge or a firewall a connection to the corporate IT network, as we saw in the previous slide. Traditionally, these PLCs and RTUs and SCADA systems, they ran on proprietary protocols. So it was obscure how they worked. And each vendor, for example, Schneider or Siemens, would have its own protocols. Not only would they have their own protocols, they'd have their own specialized hardware, and they'd have their own specialized firmware or operating system. And they were connected by copper wires. They were not connected by Ethernet. But what's happening, and what has happened now, is that there's lots of now common OT and ICS protocols, all right? Lots of common protocols. They're running on general purpose hardware. So a lot of this stuff now is running on ASICs or x86 chips, and the architecture is standard, right? And they're running embedded mainstream operating systems. Now, because everything is becoming common and standardized with the IT world, it becomes opened up to, and it's also being connected via Ethernet. It becomes open to all of the problems we see in terms of cybersecurity in the IT world. However, the difference is that in the IT world, safety is not a concern because usually the equipment is not interacting with the real world physical devices. Whereas in the OT world, the number one concern is safety and availability. And I'll give you an example of this, right? In the IT world, if I said to you, our services have an uptime of 99.5% or 99.7 or 8%, in the IT world, that's okay. That's acceptable in most cases, right? In the OT world, 99.5% means 2 or 3 days of downtime a year, right? Of unplanned downtime a year or unplanned behavior per year. If you apply that to the example of a metro train, right? The orange line in the hall cannot come off the track 2 or 3 days a year. It's not acceptable. People will die, all right? So safety and availability of the service and the functioning of the service is much more important in the OT world than in the IT world. Where in the IT world, cybersecurity is more concerned with confidentiality of data and integrity of data. So in banking, you want to protect people's bank accounts and protect their money. Therefore, you need to protect the data related to their financial transactions. All right. So the availability requirement in the OT world is extremely high. Even if you're not talking about safety systems, right? So you're not talking about a metro system, you're talking about just an oil rig. Look, if the oil rig network goes down for 2 or 3 days, that country potentially, if it relies on oil for its income, will lose billions of dollars just in 1 or 2 days of outage per year, right? It's not an acceptable loss, right? The real-time requirement also in OT networks is critical. What that means is that the communication on the network, jitter and latency, which affects the communication on the network, is not acceptable. If the controller sends a packet to the Dubai metro or to any metro that it must stop at the station, and that packet arrives a few milliseconds late, the metro will miss the doors and the metro will be misaligned with the platform, and then the doors can't open. So the real-time requirement is critical. If you have a few extra milliseconds of certain chemicals going into a water treatment plant, you can poison a whole population, right? If you have a few milliseconds delay in certain electricity network situations, distribution situations, you could probably take down an electricity network. So the criticality of real-time requirements is very high in the OT network. Another problem in the OT networks is that these PLCs and RTUs are sitting in the field, in a substation or in a factory, and they have to function for 20 years without any downtime, right? So how do you do vulnerability patching when there's updates to the firmware, for example? If there's updates, many devices do not even have updates and cannot have updates, right? The application of patches is very, very slow and infrequent. And to do security testing, penetration testing, even just basic UAT testing is very, very rare and occasional, right? And the security awareness in this space amongst the operators, so the people that wear the orange jumpsuits and are controlling their awareness of cybersecurity and their culture of cybersecurity is very, I'd say it's increasing. This is a politically correct way of saying it's low. It's not very high. They don't have much awareness, all right? So as I said earlier, these are examples of, for example, the kind of things that are problematic in PLCs and RTUs. And the reason why they have these typical, I would say, old school or very old issues that we solved in IT many years ago, hopefully, all right? In OT, they are still there. Why? Because these PLCs have been in the same factory or in the same plant or in the same metro control carriage. They've been there for 10, 15 years. They have not been touched by anybody, right? So naturally, they'll have vulnerabilities which are very, very old. And sometimes they can't be patched. So these are all PLCs you're seeing on the right, okay? So this color here, the red is ABB, all right? This is usually, it's almost 99% of the time you will see this, by the way. So this is an ABB PLC, all right? This is a Siemens PLC. This light blue or sky blue color. This color here is the Schneider color, and this one is I believe, Honeywell, right? This is the standard colors you'll see by these industrial vendors. What you will notice now here, right, is that here you have RJ45 Ethernet connections, right? Ethernet ports. Same here, but not here, right? What you see here, this silo here, this module here, these are slots that have been filled with modules. These here are empty slots. So these are expandable and you can plug things into them. These may be copper wire connections to machinery as well, right? So you may have the SCADA master connecting on one of these Ethernet ports, sending commands to this. This will process that command based upon its program logic or ladder logic and send out the commands from these connections here to the physical device. The problem is with 5G and the adoption of the digital revolution, Industry 4.0, and all of these drives towards efficiency, is that the attack surface is growing massively. So if you're interested in a career in OT, it's a good time to get into it because the field is growing in the same way that the cloud started growing maybe 5 years ago or less even, right? OT right now is one of the next, not the only one, but one of the next big things in cybersecurity, if not big already, right? So it's a good place to be. The attack surface is growing massively. And just to give you an example of that, all right, here is Shodan. So Shodan is a website. And what it does is, it's like a global nessus. It will provide you, and you choose the country, you choose the IP range, whatever you want, right? And it will give you information on all of the publicly available, publicly facing OT equipment, which is scary, all right? So you can actually search for your country or your company. And it's a good idea, by the way, that for you guys working in any industrial environment or OT environment, even banks with point of sale equipment, to search and check whether your IPs or your companies or your whatever are showing here in Shodan. Shodan is a very famous website. It's free, right? And you can check yourself and do a basic audit of what's exposed to the internet through this. Any questions? I take that as a no.
Yeah, I have a question, Kashibhai.
Sure, sure.
Assalamu alaikum. This is Atif. Thank you for doing this. So I'll be brief quickly. I have a question about IoT. So what I'm understanding in Internet of Things is I know your presentation is more about the OT stuff, but my question is more pertaining to would be as a generalized statement, would that not be the case where if you are transitioning from any Internet of Things, or for example, a refrigerator or AC system, which is smart now, which participate on the internet, or airline industry, if they are going into the TCP/IP world, then you get into the realm of things. That's one part. A comment on that. Second, how much knowledge you need to know from the traditional legacy environment into getting into the internet information, and what are the security vulnerabilities? Would that be same? The firewalls and stuff. I can take example of OT. You need data diodes to actually, transfer the information from SCADA into, the IP. But basically, you put firewalls in the middle as well. So comment on that, please. Thank you.
Yes. So data diodes are one way. So okay, let's it's a good question, and I'd like to entertain it actually. So let's go back to our Purdue model. Here we are. Here, right? So so you see here between level 3 and 4, you have a firewall, right? The traditional way of doing this was the paranoid way, if you're really sensitive, right? So they still have a use case, data diodes, is instead of having a firewall here, you have a data diode between these two levels. So this is the IT world, this is the OT world, below level 3. And level 4 plus is the IT world. So to explain what a data diode is, for those that don't know, a data diode is and I think maybe Iqbal Bhai is here, he's a specialist in this field, right? He works for a company here in Dubai. Data diodes will physically only allow packets to go one direction. You cannot send traffic back, all right? So it's one way from the OT network to the IT network, because the traditional fear was that viruses, etc., in the IT network, which may be being blocked or not spreading here because everything is patched and up to date, can spread if there's a connection into the OT world where things are not patched and cannot be patched for another 1 year or 6 months, right? So they use data diodes because they needed information they needed real-time information about their industrial network. So they use data dives to send traffic one way only. They are, depending on the level of risk, they are now, the people are moving towards using firewalls instead, because the trust in firewalls has increased, and some firewalls offer some kind of logical, you could say logical data dive. So it's not physically impossible. If the firewall itself is attacked and hacked, then you could still open up communication between both sides. But that's very rare. So it depends on your risk appetite. You can choose between a firewall or a data dial. I've not really seen a scenario where you have both, though. All right. And I think data diode solves one problem, which is between here and here. But the issue is, what about lateral movement down here, right? If somebody walks into a plant, plugs their laptop into here, into this switch, and he'll get access to everything. So perimeter defenses alone are not enough, as we know from even the IT world. The second thing is that in the case of Stuxnet, so let's go back now to the latest slide. In the case of Stuxnet, all right, which is the first major OT attack, they didn't even need a data diode because there was no connection to the IT world. It was only level 1 to 3, all right, or level 0 to 3, but they still suffered an attack because somebody, what they did was they found out the names of the operators working in the factory, and they basically targeted their home PCs, infected their USB drives, and hoping one of them would go in and plug the USB drive into the industrial network. And of course that happened. And in the USB drive was a payload, AKA known as Stuxnet. And then the rest is history, right? The centrifuges were spun out of control and the nuclear program was disrupted. So that was the first major attack on the OT network, and it proved that air gapping does not work, right? And perimeter defenses alone do not work. There's always a way to come from the inside as well. And that was not with anyone working as a spy for the Israelis, right? It was purely by mistake. Imagine if they had a spy who could just work in the factory as a legitimate employee and take in a payload to infect the network. There's that risk as well. So anyway, I think, I hope I've answered the question a little bit. Is that okay?
Yes, sir. Thank you very much.
So just the history of OT attacks. The first big one was 2010, Stuxnet, that I've just explained. The problem with this is, with all of these attacks actually, because most of them are state-sponsored or groups linked to nation states, right, or espionage. The problem with this is it's not like a traditional bomb, right? If the Israelis wanted to bomb Iran, they could throw a bomb, the bomb would explode. Iran can't pick up the pieces of the bomb, put it back together and throw it back at Israel. You can't do that with a bomb. But with Stuxnet, what the Iranians did is that they looked at the code, they found the code, they changed a few things in the code, repurposed the code, and fired it straight back at the West, right? So it's suspected, the suspicion is, nobody knows for sure, right? The suspicion is that this attack on the New York floodgates, dam floodgates, was done by Iranian hackers who simply picked up the code from Stuxnet and repurposed it. And so many attacks have come out of Stuxnet where people have used the code and reused the code and fired it straight back around the world. So every time there's a nation state participates in this kind of attack, you're increasing the sophistication of the attacks, which are then going to, by definition, become available to anybody and everybody, which makes the world a very dangerous place. And as you can see, the frequency of these attacks continue to increase, so much so that even like we know in the Middle East, we know about Shamoon. It's not mentioned here. Shamoon 1, Shamoon 2, 15,000 Aramco endpoints were disabled, right? Can you imagine how much money they lost? Aramco. Aramco is the largest company in the world, right? It's bigger than Apple. Every second they're making millions, if not billions of dollars, right? 15,000 of their endpoints were disabled by Shamoon, right? So this is a huge loss. I mean, Merck & Co was another one. Merck & Co, I mean, Merck & Co was 1 billion loss, $1 billion. It's huge. And this is only going to get worse and increase. Probably the most dangerous one in terms of public, affecting the common people and the public, was the Ukraine power grid attack. So suspected Russians attacked Ukraine's power grid and took the capital city's electricity out and made the whole city go dark. Now, if you go on YouTube, and I advise you to write this down, by the way, go on YouTube and search a documentary called 0 Days, and that explains exactly, dissects how, why, when Stuxnet was written and deployed, all right? And it gives some technical breakdown as well. That's 0 Days. It's on YouTube for free. And on YouTube also, you'll find the live recordings of operators with their mobile phones recording the control panels and how things were changing on the control panels, and they couldn't work out why or how it was happening, and the city went dark. They took out the electricity in the whole city. So this is not just Hollywood drama, this is real, and it's happening in the real world. A survey done by Forrester found that almost 90% of OT customers that they questioned had experienced some sort of breach, 50% in the last year, and all of them pretty much expected to be breached again in the next few years, right? So it's a huge problem, and this affects our civilization, right? Electricity grids, metro lines, etc. But the problem is, if you're trying to solve this problem, you have a number of problems. One is that there's lots of security vendors, correct? I mean, there's so many cybersecurity vendors out there. Obviously, I'm working for one of them, Fortinet, right? Because you have multiple cybersecurity solutions producing multiple alerts, it can be very confusing, it can be overwhelming, and then on top of that, a lack of really trained and skilled people to drill down into those alerts and really work out what's going quickly and efficiently to address the problem. This is a big problem, generally in the cybersecurity world, but even worse in the OT security world, because people in OT cybersecurity usually come from IT. Like myself, I worked most of my life in banks, right? So I come from a GRC and network firewall engineer background in banks. And now I've shifted over to OT in the last 3-4 years. But you know, there's very few people come up in cybersecurity from the OT side, right? So there's a lack of trained people. The complexity as well is a huge problem. And of course, addressing all these is expensive. To make it worse or make it better, but more of a burden on clients, is you have lots and lots of regulations, all right? So in North, and I say this to everybody, that North America or the United States of America still has the best regulatory framework for cybersecurity and IT and OT. They are well ahead, and their standards have become global standards de facto, right? So NERC-CIP is a North American standard in electricity, but lots of electricity companies outside also want to comply to it, right? Everybody's heard of FIPS, right? This is encryption standards mostly, 142. Compliance to that is applied outside of the US as well, even though it's Federal Information Processing Standards, which is related to the US government. Because their standards are so good, NIST, everybody refers to NIST, right? Even though it's applicable only in the US. The rest of the world is catching up, right? So this is one thing the Americans are quite ahead in. ISO 27000 series, originally started as BS 7799, which was a British standard, which got adopted by the International Standards Organization. So the UK is doing okay, and the UK National Cybersecurity Centre was set up around 5-6 years ago, and now it's trying to catch up with the Americans. Unfortunately, and the Middle East countries, lots of, I mean, Dubai, Abu Dhabi, and the UAE has federal and local standards as well. Unfortunately, there's not much in terms of GRC standards in Pakistan. I wish there was more. I wish the government would apply more as well, but that's a big topic. All right. So how do we solve these problems? Before I discuss how to solve some of those problems that I mentioned, I'll just introduce Fortinet for those that don't know, right? Fortinet was founded 20 years ago by 2 Chinese nationals that went to America to study, and then they stayed in America and set up their company, right? We have around 30 products, right? Most people think of Fortinet as just a firewall company. No, it's not a firewall company. Of course, the firewall is one of our flagship products, but we have a lot of different products, and I'll explain why we have a lot of different products, right? We have multiple products in the Magic Quadrant. Even if it's not number 1 in the Magic Quadrant, it's there, right? We have over 640 patents. and we are the founding member of the Cyber Threat Alliance in 2014. It was Fortinet's idea to get Palo Alto, Check Point, and others together to share threat intelligence. So the solution to the problems that we've mentioned, all right, in terms of multiple cybersecurity products, multiple single point vendors, multiple management screens, multiple management servers, Fortinet is trying to address that from a holistic point of view. So the philosophy that Fortinet comes to the market is, okay, we have Magic Quadrant products. Maybe not all of them are number one, all right? But we try to make as many as possible, at least in the Magic Quadrant, so a very good quality product, if not number one. But the benefit is not that product alone. The benefit is that our cybersecurity products, the multiple different cybersecurity products that we offer, are knitted together in something called the Fortinet Fabric, right? That is a broad integration which integrates all of our various different technologies and automates and shares intelligence between all of our different endpoint products. So to a certain extent, you could say that if you have the Fortinet Fabric, not only do you have a certain level of integration and automation, which a SOAR product would provide you, but also that the management of the whole fabric can be done from one management server. You don't have to have multiple different screens and management servers, right? So instead of having a management screen for firewall, management screen for your NAC, management screen for your endpoint protection, management screen for your email gateway, we try to provide all of that in a single kind of pane of glass. That's the philosophy, all right? And that's why Fortinet has around 30 products and is the largest cybersecurity company in the world, which is dedicated to cybersecurity, IT and OT, all right? The fabric concept, keep that in mind, because the theme throughout the rest of this presentation is on this idea of the Fortinet fabric, right? So here's an example of FortiGate, right, which is our firewall. You see it's over here, right? It's not number one, it's number two, you could say, all right? Palo Alto's is ahead as a firewall product, right? But what Gartner do not consider is the fact that the FortiGates actually, from the FortiGates, you can control the Forti switches, you can control lots of other things, right, in the Fortinet fabric, right? They're just looking at it purely from a firewalling point of view. And here, it's some of the Forti fabric products from FortiGate. So you have access points, you have switches, you have wireless or SIM card extenders, you have NAC, you have EDR, authenticator, token, multi-factor authentication token. You have, of course, FortiGates, which is the firewalls. You have a honeypot or honey network deception technology, which is FortiDeceptor. And the list goes on, right? It's a very large list. And all of these products can come in appliance form, in a virtual machine, available in the cloud as a SaaS service as well, or simply as application software that you download. However, we have something unique and special for the ICS and OT space. And this is what, of course, this is what this presentation is about, right? We provide our FortiGates, which is our firewalls, our switches and access points dedicated for ICS and OT systems. What does that mean? Two things. I'll address the second thing in a minute, but the first thing is just the physical factor. All of these devices here, so these are the firewalls, various models of firewall. These here, the gray boxes, are our switches, right? But these are industrial firewalls and industrial switches, and this is an access point, right? These are ruggedized, meaning in an industrial environment, in the field network, if you want connectivity for a oil rig, which is pumping out oil, right? And it needs to be controlled from a control room, which is 10 miles away, right? You need to have networking equipment, which may need to sit in a desert or in K2 Mountain or Gilgit, right? It needs to withstand extreme temperatures. So ruggedized means it can withstand extreme temperatures. One, all right? Actually, let me move to the next slide. It explains it much better, right? So thermal resistance, -20 to +75 degrees centigrade operating temperature, right? So it's perfect for the Middle East, and it's perfect for even Northern Pakistan, cold temperatures, all right? electromagnetic interference, right? We have a strong compatibility with EMI standards, and also vibration and anti-shock treatment, right? And the standards are here. For those interested, the details are here. We also comply to 61850 in this space. And you'll also see that mean time between failure is greater than 25 years. Here you see that, right? So the reliability is very important as well. So this is what ruggedized industrial equipment needs to have to be suited to the OT and ICS environment. Okay, any questions on this?
Yeah, Kashif, I have a question.
Sure.
Hello.
Yes.
So when you talk about the temperature, which is -20 to 75, so it means if we will put it outdoor without enclosure, it will survive?
Yes, exactly.
Okay. Because how about the dust and other things?
Yes, all of that. All of that. Yeah, the design, the sealed systems, they're designed to resist vibration, heat, dust, all of these things. And there's industry certifications for this type of equipment. And to give you an example, I've seen a 40 switch on the traffic light systems in a city here in the UAE, sitting out in the heat in the traffic light, right? And the temperatures here in Dubai and this region, they go up to 45, even 50 degrees, right? And I've seen that switch functioning. So this is what they're designed for.
How about the moisture?
Moisture as well. So this is included in, if you see, I'll go back. If you see that, so it depends on which box you choose. Some boxes have it, some boxes don't. But there's the various standards, IP20, IP40, IP67. But yes, we do have moisture resistance as well, depending on which model you choose. It depends on the use case. And we're very open to bringing new equipment if there's a requirement from a client for ruggedized, because we already have experience in that.
Okay, thanks. Okay.
You're welcome. So, of course, when you say moisture, we're not talking about rain, right? We're talking about moisture. If it rains, it's another story. Waterproofing is another standard, which if there is a requirement from a customer large enough, then we will develop that as well. It's one of the things we pride ourselves.
The first thing I said outdoor, and I'm in Saudi Arabia, so climate is almost same as UAE, a bit harder than UAE, but it's almost the same.
Yeah, same, fine. Yeah. Okay. So another thing which is important in OT and ICS networks is the speed of processing. You can't have a firewall if it's sitting in line, or any kind of IDS, IPS, anything sitting in line in an industrial network. It's problematic if the firewall introduces latency, lag, jitter into a network, right? Like I said, milliseconds sometimes is very important, up down to the millisecond level. So what we have in Fortinet, again, something unique to us, we have SPUs, security processing units, which ensures that all of the security processing is not done by the CPU, right, or the cores. Is done by dedicated ASICs chips or security processing units. And we have separate networking processing units as well. And this increases the speed by at least 15 times, right? So this is to address that problem as well. I won't talk too much about operating system or AI, because that's coming in another slide. And we've had independent testing for a lot of our things, right? So NSS Labs, which unfortunately a month ago ceased to exist. They went bankrupt because of the pandemic. But NSS Labs used to be independent testing of these claims, and they awarded us 9 recommendations above all of our competitors for all of these products here, right? Our products will facilitate you in complying with these standards, right? The products themselves don't comply necessarily to these standards because it's not the same scope, right? But the products facilitate you to comply. And this is just to highlight, in industry, we have IEC 62443, probably the most common one, where in OT, and our products will help you achieve certification depending on your what's called a SIL level or SL level or security level, right? You have 1, 2, 3, 4 different levels of security within IEC 62443, and most customers should be trying to get at least level 3. Right? Here's our partners. So because of our, remember I mentioned the fabric concept, that all of the Fortinet devices are in a fabric together. So because of that concept, other companies started wanting to integrate with our Fortinet fabric. So in terms of industrial visibility and IDS systems, Nozomi is probably the most famous one in the Middle East, all right? Clarity and CyberX are Israeli companies, so you won't see them. Dragos, you see a lot in Saudi now, all right? But they have all integrated with the Fortinet fabric. So they provide industrial IDS visibility systems, which are dedicated to ICS protocols, and they integrate with the Fortinet fabric. And we'll explain a little bit about how that works a bit later. So I'll explain the integration with these technologies a bit later, and give you some, because I used to work for Nozomi, so I know I'm probably still one of the most technically advanced people for Nozomi in this region. I'm still sometimes giving presentations for them as well, because they are Fortinet partners, very strong partners. We have partnerships with all of these, what we call control vendors. So these are the companies that manufacture this equipment, industrial equipment. They're the main vendors. They make the PLCs and RTUs and SCADA masters, etc. Right? Of course, GSIs are here. TDI partnerships here with Skybox, ServiceNow, Splunk, etc. Siemens RUGGEDCOM, which is a Siemens ruggedized switching technology for industrial environments. They actually embed FortiGates within them, and there's another slide on that, so I'll explain that later. OWL, I believe, actually does, OWL Technologies do data diodes. Okay, here are some of our clients. I don't need to talk too much about this. I think it's a bit boring for you guys, right? But we have, being Fortinet, being the largest cybersecurity company in the world, of course, we have clients all over the world, all over the Middle East. So there's quite a few customers here from the Middle East, like Diwa, and I think Murafik, Waqood is here, Suez is here, right? But even in Pakistan, we have a lot of clients, right? A lot of people. We have even a team locally there as well, right? This is just highlighting the fabric concept, explaining how many different other IT companies are integrating with us via direct connectors or via APIs. I won't talk too much about that. Again, I think it's self-explanatory. Right. So the second point, remember I said there's 2 reasons why Fortinet stands out in terms of industrial networks and OT networks. One was the ruggedized hardware. We have a large range of ruggedized hardware, unlike most of any of our competitors. They don't have the same range that we do. Secondly, right, is that we actually understand the industrial protocols. So there's OT protocols and there's IT protocols. And again, there's a big difference. OT protocols are protocols that were designed to work on copper wire or on some sort of industrial bus, which then got ported into and onto TCP/IP. So they originate in the OT world, in the ICS world. They were not designed to work in a normal way on TCP/IP, but they've been ported and adjusted a little bit, and they work in the IT world now, right? Sitting on Ethernet TCP/IP. These protocols are completely different from IT protocols. So in IT, you have HTTPS, TLS, Telnet, FTP, port 80, port 443, port 53 for DNS, etc. Right? These are the protocols we know and we are familiar with. But there's a whole OT world of protocols out there that we are not traditionally familiar with, which are now running on Ethernet, right? Running in our networks. But if the firewall doesn't understand them, how can the firewall control them, right? So when we're talking about next generation firewalls, it's easy to say, source IP, destination IP, and port number allow or block or schedule, right? That's the way traditional firewalls work, right? However, next generation firewalls, which have been popularized in the last few years, they go right up to layer 7 in the OSI stack. So what that means is in granular control of the application. So the firewall can say, not simply block or allow HTTPS or HTTP on port 80. The firewall can say, oh, you're connecting to YouTube. We understand this application. And the policy will be allow viewing, but block uploading of videos. You have granular control of the application, right? In the same way, this is next generation firewalling, right? Or for example, Telnet, right? You can say, allow certain commands in Telnet and block certain commands in Telnet. In FTP, allow downloads, block uploads, or allow uploads, block downloads, right? You get granular control of the application. This is next generation firewalling, and all of the firewall vendors are claiming to do this. However, we are doing this in the OT space, not just the IT space. So, for example, and of course, the same applies not just to firewalls, but to ICS, so IPS and IDS as well, right? Intrusion detection and prevention. You can't detect and prevent intrusions if you don't understand the protocol. You have to understand the OT protocol to understand when somebody's trying to exploit it and then block it. And we have over 1,800 application control and IPS signatures, like it says here, for the ICS and OT space. Excuse me. And this is just one example of one protocol that we control in the firewall, in the FortiGates. This is a very well-known DMP3, is a known OT protocol. And as you can see here, we have 244 granular controls just for DMP3. So, for example, you could allow, let's have a look. You could allow DMP3 read, which is one function, right? You could allow select, you could allow start, but you do not allow stop application, and you do not allow operate, right? So it becomes like a read-only through the firewall. This is one protocol, by the way, DMP3, all right? And here's a list of the industrial protocols that our firewalls and our IPS IDS software understands, right? DMP3 was one example I showed you in the previous slide, and that's here, right? DMP3. But we do the same for all of these protocols. We give you granular control. So this is a unique point that if you want to have a firewall in your industrial or OT network, that firewall has to understand the industrial ICS and OT protocols. Otherwise, the firewall is useless. And not only that, it has to understand the OT protocols so that when Nozomi or Dragos or Clarity or Silent Defense from Forescout, these are industrial IDS systems, when they send an alert to the firewall needs to understand what that protocol is and block it, right? And here's a screen just showing the amount of controls, functions, etc., that we understand compared to the nearest competitor in terms of protocols. So look here at BACnet, which is a very famous buildings control protocol, right? 131 functions versus 31, and nearest competitor. Some of them are 0, right? And you can actually you can check this, right? You can ask when you speak to firewall vendors in the OT, and you're interested in the firewall for your industrial or OT network, you can ask not just how many protocols they support, because they will tell you, yeah, we support Modbus, we support OPC, we support Siemens Step 7 and SafeNet, or etc. Profinet. They'll tell you, yes, we support all of them. But then you ask, how many functions do you support within that protocol? And that's the important part. Is that clear about the OT protocols? The fact that they're different? Yeah.
Kasha bro, I have a question. Being a layman, if I don't understand OT things, so in my environment, if I want to know where exactly we are using such protocols, being in IT mainly, or in IT sec, or in IT service delivery, what are the things around us where we have these, like we are talking about access control, our BMS, our CCTVs or stuff like that, or something else, or our machinery, which is controlled over the internet, stuff like that.
If you remember, let's go back here. And I will come to this in more detail. Actually, this is where Nozomi comes in, right? These products here, up here, top left, they give you the visibility, right? One of their jobs is to give you the visibility, meaning you take a Nozomi appliance, right? And Nozomi have presence in Pakistan as well, by the way. You take a Nozomi Guardian appliance, you take a span port from a switch, and there'll be a diagram coming up on this later as well. You take a span port from the switch. So you span all the traffic, mirror all the traffic to the Nozomi appliance. So there's no interference from the Nozomi appliance because the traffic is one way only. The Nozomi will do deep packet inspection and give you visibility of your network live and show you all of the OT and IoT protocols that are running in your network. So the first stage is discovery and visibility. And that's exactly the job of companies like Nozomi or Dragos or Clarity. That's a good start, I think. I can recommend to you some, if you don't want to purchase the Nozomi product, I can recommend to you certain companies that have a roaming license with Nozomi. So they have the box, they come to your site, plug it in for maybe 1 week, 2 weeks, collect all the information and provide you the visibility, all right, of where and what your industrial networks are doing. But if you are sure that you have OT networks like BMS, etc., CCTV cameras, even the point of sale systems communicating on your network, the best thing is actually buy a cheap Nozomi box to start with, just do some discovery, and then decide if you need more. Or do a POC with Nozomi, and it'll actually be done for you free, right? It'll give you a visibility of what you have, and then you can decide to build a business case to purchase more as well. We'll come to a slide on this as well, by the way.
Okay, I'll be ready.
I talked about the industrial protocols here. Here's a bunch of them. This is not all of them. We cover more, and every month we're increasing the number of industrial protocols we cover. Another thing we do, this is not unique to OT, and this is not unique to Fortinet, right? So this is not a selling point in itself. The unique thing is that Fortinet is doing it for OT. So for those that are familiar with vulnerability shielding or virtual patching, they mean the same thing, all right? So traditional IPS signatures, what they're doing is they will alert based upon attack signatures. So hash files, if they see certain hashes going across the network, if they see certain IOCs going across the network, if they see any kind of attack signature, then the IPS systems will alert against it, right? So it's an attack-centric approach, right? That's why it's called IPS, right? Whereas our virtual patching or vulnerability shielding, what we do is, and not just Fortinet, all of our competitors can do this as well, right? Is that we look at the endpoints on the network, and if we see, for example, SMB version 1, because it's a big problem in OT networks where you still have Windows 7 HMIs or Windows XP HMIs still running in the OT world, and you are not allowed to change it because the OT team will not allow it. When you see that Windows 7 system running, of course, it's going to have SMB version 1, which is, for a start, vulnerable to WannaCry, which was a disaster 2 years ago, 3 years ago, all right? What we do is, if you think of the stages of an attack from a hacker's point of view, the first stage is kind of discovery, right? Scanning and discovering. When the attacker will scan the network and there's a Fortinet gate sitting in that network, not just an attacker, anybody, when anything scans the network, Fortinet will respond, all right, by not allow responses that give the information that this is a Windows XP box, which is vulnerable to all of this list of CVEs. So it's CVE based, all right? We hide all of the CVEs that are visible to us on the network to give the impression that the endpoints have already been patched. So they're not vulnerable to that exploit. And here's an example of, so this is now the unique point, right? Is that because we understand industrial protocols, we also do the same for industrial devices. So this Schneider PLC, all right? We've shielded, and as to the date of this slide, I'm not sure. I think it's around 6 months old. I'm sure it's more now, right? We have shielded all of these CVE rated vulnerabilities on this Schneider PLC, right? So you can see the CVE numbers. When somebody scans this PLC network for vulnerabilities, or even just a normal scan, because it's not sometimes normal for some applications to scan, they will not see all of these vulnerabilities that exist. And if they don't see those vulnerabilities, they will assume that they are patched, all right? Of course, if you have Qualys or something like that, that's scanning for vulnerability management, you have to create a rule to allow that in the firewall. But by default, if you switch this feature on, these vulnerabilities appear to be patched. So that's why it's called either what's the two terms? Vulnerability shielding or virtual patching. It means the same thing. Is that clear? Another thing we do, this requires microsegmentation. This requires a 40 switch as well, right? So this is again the fabric concept. The fact that our switches, which come as ruggedized switches as well, integrate seamlessly with our firewalls to the point where when you physically slot in a switch, put it on the network, you can manage and configure it from zero by the firewall. You don't even need to touch the switch or access the switch. Directly from the firewall, you can configure it. And if you enable this microsegmentation in the firewall on these switches, what will happen is, so traditionally the problem is that if I plug my laptop into this switch, this is assuming you don't have NAC, by the way, right? Even if you do, if my laptop passes the NAC profiling, then this can happen, right? I plug my laptop or I have something connected to this switch, I can access other devices on the same subnet in the same broadcast domain and compromise them. So you can have lateral movement, you can have a spread of vulnerabilities or exploits laterally in the same network, all right? The firewall is not sitting inline, so the firewall can't do anything about that, right? This is what happens in a normal switch. So it'll happen in a Cisco switch, right? What we do is, if it's a 40 switch and a 40 gate firewall over here, we have something called FortiLink, which is a dedicated connection between the switch, a physical connection between the switch and the firewall. The traffic, rather than simply being switched by the switch, the metadata sent up to the firewall will make a decision based upon the rules that you set and then allow or deny that traffic, right? It will block direct connections through the switch. It will enable them through the firewall once the firewall allows or denies it, right? So this is how we achieve micro-segmentation. And here's another way of looking.
Sorry, Kashif, just one quick question. Can you go back to the slide, please?
Yeah.
Yeah, so the concept of micro-segmentation, you are implementing it through the Fortinet firewall as well. So can it be achieved directly through the switch? So like we have certain kind of ACLs or something, or we need to have a firewall to have this happen?
You need to have a firewall because you create the rules in the firewall. You don't really create ACLs. ACLs are not intelligent enough, right? So you may want to allow certain functions of industrial protocol and deny certain functions. Only the firewall will do that. So you need a firewall. Okay.
Perfect. Thank you.
So the connection between the switches and the FortiGates or the firewalls is called a FortiLink. It's a Fortinet proprietary protocol, which is very efficient and quick. And here you see this example of microsegmentation applied to the level 1 network. So instead of, if somebody can walk into a factory floor or plant, they can plug in to one switch and then access everything on the same VLAN. No longer the case if you have FortiLink up to the FortiGate. It goes through the firewall rules and the decision will be made, right? Yeah, FortiAuthenticator. FortiAuthenticator, I think, is self-explanatory. There's nothing exactly special for the OT world. It's a, IDAM or Identity and Access Management Server, along with FortiToken, which is a two-factor authentication, which is useful in IT and OT world. It's not something unique that we offer in the OT world for this, except the fact that these servers, FortiAuthenticator servers, are part of the fabric, and therefore intelligence about any kind of vulnerabilities also shared with them. These authenticator servers are more relevant in some senses for the OT space because of large industrial sites, plants, etc., where the workstations of the operators or the master control room or MCR may be sitting remotely away from the equipment, which is maybe 10 miles in the desert or something like that, right? So you need remote access solutions, and we provide that. Here's the example. So this is the firewall, right? So remember I mentioned that the firewall does some profiling of endpoints and can block CVEs. You can configure switches from the firewall, and this gives you some level of visibility, right? And it's already fingerprinted the endpoints in the network, right? So this is an example of what the firewall can do. And what you can manage from the firewall. Here you see switches, you see access points, all managed. If you double click on this, right click on this, you'll be able to manage this access point. You'll be able to manage these switches here as well. And you can see an example of that here. So here you see switches and switch ports actually being managed from the firewall. So again, you see here, FortiGate, this is inside the firewall. You're doing this, right?
Kashyap, do we have an IPS module for OT within this firewall as well, or it's separate, or it's not there?
No, you have an IPS module. You can either buy the license. I mean, it comes in most of the licenses by default anyway, right? But you can have an IPS module. You can you have various different modules running within it, right? So the FortiOS is the foundation for all of this. The FortiOS with which module you license will give you the firewall, give you the IPS, give you the many different things, right? VPN modules. There's lots of things you can do.
Okay, thank you.
Right. NAC being another one, right? So FortiNAC does profiling of your endpoints and makes decisions and helps you make decisions on your endpoints. Again, if you don't understand, you can't profile industrial equipment, then the NAC is not as effective. So maybe, I'm sure the other NACs in the industry are higher than us in the Magic Quadrant. However, the advantage we have in the OT space is that our understanding of endpoints and therefore profiling them and making decisions upon them is much more granular and deeper in the OT space. And it's the same with the sandbox. So we may not have, you know, again, the #1 sandbox in the world according to Gartner. However, we do, it's in the Magic Quadrant, so it's there as one of the best products, all right? The threat intelligence we provide for the OT space, we believe is #1 in the market. And we also have dedicated sandbox functions. You see here, Modbus, Siemens Step 7, etc. You see you have lots of IPS signatures for, again, in the sandbox for industrial protocols. And keep in mind the sandbox in relation to FortiGuard Labs. So you see here, FortiGuard Labs, we have a dedicated slide on that. So keep in mind that the sandbox is utilizing FortiGuard Labs, which again is a unique advantage we have. So not just the OT protocols, but the threat intelligence as well. And the same.
Sorry,
yes.
Kashyap, just if you can go back on the sandboxing. 2 questions. One is, can you let me know like which hypervisors are you guys using for the sandboxing? Like it's Windows, Microsoft, or the VMware that's being used. And the second thing is, and specifically, like you've mentioned about the FortiGuard Labs, right?
Yeah.
So if you are performing the sandboxing within the OT, so does it need to communicate in real time with the FortiGuard Labs to fetch the information, or it can be taken offline? Because, you know, OT is pretty much restricted.
Yeah. So we work both on VMware and Microsoft, right? So that's not an issue. I think even Oracle as well. And I think
no, sorry. My question was, what hypervisor is used within the sandbox itself? So I know, like, you can mount this sandbox on the Windows and VMware, but what's running within itself?
That's a good question. I don't actually know the answer to that. So I'm going to share I'll share my email address, and you can send me an email with that question. In fact, I'll do that now. Otherwise, we would forget, right? So where's the chat?
That's fine. I already have your email. That's fine.
Okay, fine. Okay.
Yeah, but if you can also explain about the FortiGuard Labs thing. So it has to be online direct access, or it can be done offline?
Not required. It's not like Carbon Black. It's not required.
It's not required. Okay, thanks.
So FortiDeceptor. So what this is a honey network, right? Or honeypot network, or the different terms for it. But essentially what we do is, if you have a FortiDeceptor server on your network, what it will deploy, as like other honey networks, right? And we know there's a market leading one as well, which is very famous, right? Again, we deploy virtual machines on the network, and whenever somebody touches those virtual machines, you get an alert, right? And it will observe that behavior and generate IOCs based upon that. This is not special to Fortinet. There's other products that are also honey networks, right? However, again, the difference in FortiDeceptor is that we also create industrial, you see all of these, right? These are industrial deceptors. So you have a package within FortiDeceptor. If you buy the license, you will actually be able to deploy Deceptor PLCs and RTUs. Right? FortiSIM, I'm going to skip this slide because the FortiSIM is quite standard. There's nothing related to OT there. And same with FortiSOAR. SD network. So I'm going to quickly explain this. If you need more explanation, please do email me. I think I should just put my email there anyway, because so everybody can have it. Typing it now. So I'll just put my email in the chat. All right, so you can all email me questions, comments, or more information. I can, if you email me, I'll share this deck with you guys as well. All right. So SD-WAN. So people think of SD networking as software defined. We call it security defined. So we don't even call it WAN anymore. We call it SD network, right? Because it's not necessarily for WAN use cases. What SD-WAN started as is, to give the basic idea, is multiple ports for a WAN connection merged into one virtual port, and then decision based upon jitter, lag, latency, or other rules decides which port you use to send the traffic. All right. So here, for example, on the firewall, you have 3 ports. All right. One could be MPLS, one could be internet, IPsec over internet, which is a VPN technology, right? And then another one as well. And a decision is made within the firewall for which port to use to send the traffic. So you may want to use critical traffic on the MPLS, right? You may want to send other traffic, not so critical, through the internet, and some other traffic which requires more confidentiality through the IPsec connection across the internet as well, right? This is traditionally used for WAN technology. So if you have a remote office, you have multiple redundant links, one, say, MPLS, one internet, one maybe 4G, 5G, right? And the SD-WAN provider will decide which one is the best route based upon various factors like bandwidth or latency or jitter, and what your priority is, and which traffic is sensitive to jitter, which traffic is more sensitive to bandwidth, right? Videos, right, in video calling, doesn't matter if there's some jitter, doesn't matter if there's some latency, right? But they need bandwidth more than sensitivity to jitter. What we do here is we actually apply this to the industrial network. So certain industrial functions and certain communications, which from level 1 up to level 4 may be critical or may be extremely important to keep up. So you may have, for example, multiple 5G cards connected to send the traffic up. And if one is down, send it 3 other ones. So it gives a kind of high availability at the port level, right? You may have one which is a 4G connection, which is the normal one for a field device sitting in the desert somewhere, right? And it may also have an internal modem that if that fails, you can dial up this way as well, right? So this is the use case for SD networking within the OT space, right? And it's something we have by default, no extra license, no extra cost, built within the firewalls. So FortiGuard Labs. So I mentioned earlier that we are one of the founders of the Cyber Threat Alliance, which was sharing threat intelligence, right? But our FortiGuard Labs ingests threat intelligence and threat feeds from over 200 semi-open sources, so NATO, Interpol, which is the United Nations kind of body or international body for police, Europol, KISA, and the Cyber Threat Alliance, and another 200. But we also take threat intelligence for our participating customers. So it's almost 500,000 participating customers. All of that adds up to over 100 billion events per day. We obviously processing 100 billion events a day manually by human beings is impossible, right? Unless you have a huge team. We have been running machine learning and AI platform called FortiAI, teaching FortiAI, which is a deep neural network, since 2009 or 10, so around 10 years, it's been learning the behaviors of attackers worldwide and taking threat intel from that. And then we produce, as part of our threat feed, prevention signatures against known attacks, IOCs against unknown attacks, and of course, intelligence playbooks and instant response. The unique thing, again, is that we also do this, produce these IOCs and signatures for the OT protocols, and our threat feed is vendor neutral. So we provide our threat feed, unlike most vendors, by the way, in the standard taxis, from taxi servers in STIX format, right? STIX format is usually for open source threat intelligence sharing, right? We provide that as part of our threat feed, and if not STIX, in a CSV file, right? So you can do what you like with it. So even if you don't have a FortiGate, you can subscribe to a FortiGuard Labs and receive this threat intelligence. FortiManager is our management server, which is
Sorry, Kashif, one question on the threat intelligence. So the license comes, do we have to buy a separate license for this, or it would come with other products that we have, for example, maybe firewall or maybe same or other thing?
Yeah, so when you purchase a firewall or a NAC or email gateway or whatever, right, you have a choice of bundles for your license, right? You can purchase individual licenses, or you purchase bundles, which are packages, right? So it's up to you whether you choose a separate license or a bundled license. But you have to, if you want this service, you have to subscribe to it. Yeah.
So it's a paid service, yeah?
Yes.
Okay.
But like with the firewalls, with depending on which firewall, you get it free for 1 year, right? Most of them, most of the packages you'll get at least for 1 year free. IPS updates, FortiGuard Lab, threat intelligence free, right?
Right.
And that depends. Okay. It depends on how tough you are in negotiations with your sales guy as well, right?
All right, that's fine.
Kashif, bro, I have a question. If we have a FortiGate firewall, can we get these licenses as POC?
Yes, you can. You will get it as POC. Yes.
Okay. Fine. I'll try to get some.
So this is an example of applying Nozomi IDS and visibility guardians in an industrial network integrated with Forti switches and Forti gates, right? The partnership with Nozomi is very strong, right? The partnership with Nozomi is so strong that there was no issues of me moving from Nozomi to Fortinet, right? And I speak to my old bosses and almost 3-4 times a week because we're working on so many things together. For those that don't know, Nozomi, their speciality, I think it's probably a good idea to show you a quick video. Do we have time? Is there any time limit on this presentation?
No.
Okay, good. Right.
No, there's no time limit.
Okay. I actually have a demo, which I mean, Nozomi is still using my demo videos, right? Which is funny. And I have those demo videos from my Nozomi days. And you'll see, you'll understand the difference, because the difference is not so clear. What's the difference between FortiGate IPS and Nozomi IDS, you could say, right? So I will find this video. Let me see if I can share this.
You can see here, there's live traffic being fed to this device, and it's showing.
Trying to share this video 1 minute.
Okay, guys.
I hate it when they when Microsoft strips out all the controls. You have to try to find where they are, trying to make your life easier, then make it more difficult, right? Can you see the video I've just dragged across the screen?
Not yet.
Okay, right. Yeah, I know what the problem is. Okay, so first what I'll do is I'll explain what Nozomi does is it takes span or mirror traffic from the switch, right? So everything this switch is seeing, it also copies a copy of that packet and sends it to the Nozomi device, right? And it's one-way traffic only from the switch to this Nozomi Guardian appliance, right? So it sits next to the switch, you could say. This is one way, so it's not interfering in the network traffic. It's like a read-only traffic, all right? And what it does is when it ingests that traffic, it does DPI, or deep packet inspection, and this is the result. So I'm now going to share the video. Screen 2. Okay, now you can see it, right?
Yep.
Yep. I'll just turn the volume down on this because I can explain it myself. So this is the Nozomi screen. As soon as you plug in that span port to the Nozomi box, this is what happens. It starts picking up traffic immediately and starts telling you this is a PLC, this is a SCADA master, and it gives you the protocol details. Like you can see Modbus, you can see the IP address. And as it continues doing deep packet inspection, it actually identify what type of PLCs these are. So it will tell you this is a Schneider PLC, this is a Rockwell or a Siemens. It tells you this green one here is a HMI, right? And the color coding, if you click on here, you can, on the question mark, it will tell you what the color coding is, and you can change that color code to what you like, right? And here it's telling you SCADA master, SCADA slave, a terminal, which is HMI, etc. So this is a live, real-time visibility of your industrial communications or your OT communications. If you notice here, it's also picked up now the DNS names of these devices. And if you click on one of these, which I will do in this video in a minute, it will also tell you more details about each of these PLCs or RTUs. You see here it's picked up the CCTV camera network. So you can drag that to one side to give you visibility. So this is the beauty of Nozomi and its competitors, is that they give you this very detailed and granular visibility, right? For discovery of your OT network, because most OT clients, they don't know. And you can change the views, the colors, to tell you, for example, what is trying to communicate with the internet. And here it's showing that this red box is an external internet address, which means this HMI has probably been compromised and is trying to dial home to a command and control center. Let me just drag this across because I want to show you something else. All right, so this is the network organized as per the Purdue model. So it will organize it as per level 1, level 2, level 3, etc. All right, and it gives you live, and you can organize the network in different ways. So here, if you click on one of the PLCs, you'll see the details. So it's telling you this is a Control Logics Rockwell Automation PLC, its firmware version, its serial number, and all of the hardware components as well. So if you remember the slots that I showed you in the PLCs, here is telling you what those slots are and the firmware versions within those slots as well, right? MAC address, vendor, vulnerabilities. It's a A to Z solution in terms of visibility into your industrial network. I hope that picture is clear of what Nozomi does. And based upon this detailed knowledge that Nozomi or its competitors will provide, it generates alerts when it sees anomalous behavior. So what Nozomi will do is baseline this network, baseline all of these details, baseline all of these slots within the PLC, right? So here you're seeing 12 slots. And if it sees any changes in the installed software or firmware, any kind of change in the logic, in the ladder logic, the project files, the function codes, the variables and values which are sent from the PLC to the machinery, it will raise an alert to the firewall, and the firewall will do the blocking. So let's go back to this here. So you see here that Nozomi does not sit in line, right? Or let's not call it Nozomi, let's call it the industrial IDS, does not sit in line, right? It sits just off us like a stick, right? Receiving the copied traffic from the switch. When it sees something strange, anomalous against what it's learned or baseline from its machine learning, it sends an alert to the FortiGate, to the firewall, and it will say, look, block this traffic, and the firewall will do the blocking, right? And that's the same here between level 1 and 2, and between level 2 and 3 as well, because sometimes the commands or the exploits may come from up here as well, down into the
bro.
Yes?
So if we have FortiGate firewall, but not 40 switches, still we can use the Nozomi. Is it compatible with other vendors?
Yes, the Nozomi is compatible with anything that can provide it packets. It just takes more packets. Doesn't care whether it's a switch, doesn't care whether it's a router, doesn't care about anything. even a packet broker, right? Like there's many packet brokers out there. Anything, as long as you feed it, it's you could say, right? It will eat anything.
Okay. Got it.
The integration with the firewall is important, because if the firewall does not understand the language of OT protocols, again, the firewall cannot block it, right? So if we look at, this is just a comparison. I think I've explained the comparison between the two in a much better way, right? I'll come back to this slide, if you don't mind. This is the integration, right, that Fortinet has with Nozomi. So this is a Nozomi screen, not a FortiGate screen, right? You put the IP address of the firewall, the username and password of the firewall, and then you choose what you want to do from all of these different options in the FortiGate, right? So this is FortiGate's integration with Nozomi. If you look at Palo Alto and Checkpoint, the integration is I believe Palo Alto is more mature now, so they have more options, but it's still not as much as what we have with FortiGates, right? Checkpoint is quite far behind compared to Palo Alto and towards FortiGate. So this is the very tight integration we have with the Nozomi. A lot of the time, although Fortinet is a much bigger company than Nozomi, Nozomi is a startup, right? They started in 2013 because industrial IDS systems and the need for them was not something the world recognized until after Stuxnet. So they started in 2013. The integration with us is much more deep and granular. On top of that, we have a partnership with Siemens, right? So Siemens have RUGGEDCOM switches. These are very famous switches used in the industrial world, dedicated to OT and ICS. And within these switches, you have two modules. This is the RX 1500 range. One module will be like a Nozomi box, and the other module will be a FortiGate firewall. And this is all integrated within the switch. So no need for span ports, no need for anything like that. This is all within one box provided. And I believe, I think we're going to probably see the first deployment of this architecture with Nozomi and FortiGate built into RUGGEDCOM switches in the first 6 months of next year in Pakistan, and a very large company within Pakistan as well. I worked on the POC for them, so that's how I know. I will skip this because I think I've covered this individual products within FortiOS. This is like a summary slide, all right? Let me just go back quickly to the IEC 62443. So those interested in GRC, right? In the OT world, the gold standard, you could say, or the most famous standard is IEC 62443, which is mostly relevant to the electricity industry, all right? And this is an IEC 62443 kind of compliant architecture, and it's showing you all of the different Fortinet products spread across the whole architecture, and where they're relevant and where they'll sit from an architectural point of view. And here you even have Nozomi boxes as well here, you see. So the Nozomi management servers are here, and the Nozomi actual Guardian boxes are here, right? And they're no longer called SCADA Guardian, because Nozomi have, I think maybe 2 years ago now, when we were in Nozomi, we said we want to cover much more than just SCADA systems. We will cover all of OT and all of IoT and all of IIoT. So IIoT is industrial Internet of Things, and IoT is anything, kind of any device, fridge, freezer, kettle, anything which is connected to the internet, you could say. That's it, right? Any questions? I know it's been a very long presentation. This is a nice place to stop.
Yeah. Kashif, just one question on the sandbox. So I'm assuming that the FortiSandbox, it covers both IT and OT.
Sure.
And when we talk about OT, it covers all the function codes that you talk about. Like there's no limitation to it. Like it provides a very in-depth analysis.
Okay, so
under the code level.
I will be honest with you. The sandbox, the amount of OT protocols it covers is not as much as the FortiGate yet, but it's catching up. Right, so we're still developing that product to make it to give it the level of granularity that the FortiGate has. So because FortiGate is our flagship product, that's the one that we've been developing for years, and therefore we have a lot of granularity there. The Sandbox, if you have specific protocols you're interested in, I can find out for you if they are supported or not in the Sandbox.
Okay. All right. Thanks.
Assalamu alaikum, Kashif bhai. It was really nice presentation, very comprehensive. Just very simple questions. If someone want to come into this area, what are the key certification the person needs to do? That would be really helpful.
That's a tough question, depending on which part of OT you're going into as well, right? So if you're going into electricity distribution, transmission, generation, etc., then the IEC 62443 is a good one, right? SANS have what's it called? The SANS GICSP is another good one, all right? But SANS are quite expensive, but you can study the books yourself. Nozomi and Dragos have certifications on their product. Of course, Fortinet also has free training up to NSC 4, I believe. And if you're a partner, up to NSC 7 in OT as well. So you can go on training.fortinet.com. In fact, I'll type that in the chat now. So got it. You get training from there as well, all right? So, I mean, depends which area you want to go to. I mean, if you want to focus on IoT or IIoT, then actually the cloud becomes very relevant. So Amazon and Microsoft have certifications related to IoT or IoT as well, right? So it depends which area you want to go into.
Thank you very much.
Sorry for the non-clear answer, but so IEC 62443 is a good start for because it's used outside of the electricity as well.
Kasha bro, I have a question.
Sure.
If we don't have a BMS in place and we are managing our electricity with the traditional panels, still we can use these devices to look at the traffic and everything?
If you're using traditional panels, then you don't have BMS system in place, then the traffic is probably not on the IP network, right? It's probably directly connected.
Kind of, but there are always panels are involved where they have the circuits and everything. And somehow, probably on a panel, they connected one or two things which are over the IP. Somehow there will be, because most of the companies where they have the old system and they are bringing the new technology, they are integrating both with like XYZ with their own style, but they are integrating two. Also, I'm in an industry kind of oil field shit. So they are also doing the manufacturing. We have power, which is like
traffic, then the answer is yes. If it's on the network, then you can use Nozomi and you can use FortiGates, etc., to control and give visibility on that traffic.
Okay, but we don't have the base infrastructure all with FortiGate, but we do have devices for the FortiGate, and even in future probably we'll have a larger network where we have power, IoT solutions, and everything, but not on the FortiGate devices itself, all over the infrastructure. So still we can use Nozomi and FortiGate.
Yeah, you can. But right now it's nowhere near. So the main advantage that companies like Nozomi have or Clarity have over its competitors is the number of protocols they support. Because the nature of OT, IoT, ICS, there's a huge number of protocols. So the more protocols they support and the more depth and granularity of protocols they support, the more competitive they are. So Clarity and Nozomi are at the top. Centrio is maybe position 5 or 6, I think, right? Because Nozomi and Clarity are normally number 1 or number 2. And then after that is Forescout, which is a silent defense product, previously known as Security Matters, and Dragos as well. Dragos have their own product as well. So Centrio is quite far behind.
So you are saying, okay, by the way,
By the way, these are all partners of Fortinet, right? So wearing my Fortinet hat, I'm kind of vendor neutral. but obviously I have opinions on national security and these things.
Okay, so for even the IoT solution like RFID system and all those things, we can monitor through Nozomi and we can integrate.
Yes, and the good thing about Nozomi is if they find a protocol that they currently don't support, what they'll do is you can actually, within Nozomi, the Guardian, you can do a packet capture. So it captures the traffic for 1 day, 2 days, whatever the cycle is, right? Capture that traffic. You then send it up to Nozomi's labs. They will pass, dissect, and then produce the signatures and the passing of that protocol within a few days, right? Sometimes they do it in a week, sometimes they do it in 2 weeks. So it's very quick to adopt and support new protocols. Then what they do is they also share some of that information with Fortinet, who will then also take longer because firewalls are a much more complex product in some ways, but we'll also eventually support those protocols as well.
Perfect. Last question. If I want to have a POC, like I already have a firewall from FortiGate, not using it till date. I got it like 6 months back. So, but like we'll have like our production machines, we will have around 70 production units in one place. So because the vendor want us to open some ports for them to monitor what we are producing on those machines. Those are like highly confidential stuff they have on those machines. So but they want to monitor it like what we are producing on those machines. Same time, we can also monitor like what they are watching from those machines, right? Through Nozomi.
Yes, correct. So what you can do, send me an email. I'll put you in touch with the Nozomi team and they can do a POC for you.
Perfect. Saudi Arabia, तो भाई मेरी English मुक गई उन्नाली. ठीक हो गया. I'll be waiting, and I'll be in touch with you because
किसना पता कि मैं भी पंजाबी समझना.
मैंने आज मेरी मुक गई है. Anyways.
Kashi bhai, बहुत अच्छा session था. Thanks a lot.
You're welcome.
So it was very good session, and to be honest, it was all mostly new stuff for me because I never worked in the industry or in the OT side. So I may have to watch it again, you know, to understand many things. But I hope it's a long session, but very useful. So thanks a lot for your efforts. And Mashallah, you are a very senior guy, very experienced. So I hope you do more sessions with us. And you can like like even I think OT itself has many different I believe areas. Maybe we can focus on 1 or 2 areas just to make a focused discussion. Thanks a lot.
I can do another deep dive maybe into Nozomi. It would be useful.
Yes, yeah, definitely. This was very good actually. It was a very good for anybody. Most of us may not have much idea unless somebody is here from the industry himself and working on this. Looks like Fahad is working on this one, I think. But okay, thanks a lot. It's very useful. Okay, guys, thanks everybody for attending. We'll finish the session now. Okay.
Thank you very much. Really appreciate that, Kashif. Thank you.
Thank you, Kashiv. Thanks.
Thank you,
Thank you,
Subhani. Okay, bye-bye. May I will finish the session now.
Thank you.